Galileo Galilei was born on February 15, 1564, in the Italian city of Pisa. He was born at the time when religion was on its peak, where whatever science said, churches had conflicts. If any scientist or a person says anything against the church or the Bible, would surely face consequences and punishments. Galileo Galilei had major contribution in field of physics, mathematics, astronomy, cosmology, and philosophy. He found a thermometer, compass, hydrostatic balance, and Galilean telescope. Galileo studied various things including the pendulum, the law of falling bodies, planet Jupiter, sunspots, objects in motion, and various astronomical studies. He was greatly admired by notable scientists like Albert Einstein and Stephen Hawking. In fact, the term the father of modern science was given by Albert Einstein. Galileo Galilei was the eldest son of Vincenzo Galilei. His father was well-known composer who played the lute, and Galileo also became skilled lute player just like his father. Galileo attended the monastery school at Vallombrosa in his teens. His father wanted him to become a Catholic priest or a doctor of medicine, starting a medical course at the University of Pisa when he was 17. Aged 18, Galileo stumbled into mathematics, changing his life and the course of scientific history. Mathematics seemed much more interesting to him than medicine, and he quickly realized that mathematics and philosophy seemed to play a crucial role in understanding and explaining our world. In 1585, Galileo left the university without having obtained a degree, and for several years he gave private lessons in the mathematical subjects in Florence. He also began his studies on motion, which he pursued steadily for the next 2 decades. Galileo became fascinated by the movement of pendulums, noting that if the length of the string was constant, it didn't matter how hard you swung it, the pendulum always moved to and fro at the same rate. Galileo believed that mathematics is the language of the world around us, whether it is the behavior of planets and pendulums or the fundamentals of music and mechanics. All could be understood using mathematics. At the age of 22, Galileo published a book about hydrostatic balance he had invented. In this way, his name became known to other scientists. Having strayed from medicine, he decided he might as well study art and drawing in addition to science. Despite his scientific progress, Galileo's first job was an art teacher. Aged 24, he began teaching art in the Italian city of Florence. He didn't stay long in this job. His scientific and mathematical powers had been noticed, and in 1589, aged just 25, he was awarded the chair of mathematics at the University of Pisa. He worked in Pisa for 3 years before moving to the University of Padua in northern Italy in 1592. Galileo settled in Padua, where he taught mathematics, physics, and astronomy, making many momentous scientific discoveries. Once he saw a swinging lamp in a church. He carefully observed its motion and noticed that the lamp swinging back and forth is traveling the same distance. While there were no clocks back then, Galileo used his own pulse to measure the time. Based on this, the laws of pendulum were discovered. This experiment had a profound impact on the field of physics and also led in the development of the understanding of timekeeping. Galileo realized pendulums could be used to keep time, but never seemed to have put this into practice, after which clocks were invented. Galileo is fundamentally responsible for what we know about the space today. While it is believed that telescope was invented by Galileo, that is not the case. First telescopes were made in 1608 in Netherlands by spectacles makers Hein Lippershey, Zacharias Janssen, and Jacob Matthias. However, in 1609, Galileo heard about the Danish perspective glass and constructed his own telescope and became a skilled telescope builder. He made money selling telescopes in Venice to who were eager to see which ships were arriving as soon as possible. At first, the telescope had 3 times magnification. With some refinement, he made it 30 times. Soon, Galileo turned the telescope towards sky. The first thing Galileo observed was stars shining near the planet Jupiter and figured out that they were moving around, discovering the first moons ever known other than Earth's moon, which were Io, Europa, Ganymede, and Callisto, are also known as the Galilean satellites in his honor. He also discovered that Venus has phases like the moon, ranging from a thin crescent to full. This was the first practical observational evidence that the sun sits at the center of the solar system. Galileo also discovered of the rings of Saturn, although he was fairly confused. He also discovered our moon has mountains and that the Milky Way is made up of stars. He was the first person ever to see the planet Neptune, of which he had drawn drawing in his notebook. He also observed that it was moving, unlike the other stars, concluding it as a planet. At that time, the planets Mercury, Venus, Mars, Jupiter, and Saturn had been known of for thousands of years, and no other were thought of for a very long time. Later, Galileo lost track of the Neptune he had found. Neptune was not discovered until 1846. Shortly after his first telescopic observation of the heavens, Galileo began sketching his observations. He wanted to get his findings out. His observation and interpretation of stars, the sun, the moon, Jupiter, and the phases of the planet Venus were critical in refining our understanding of the cosmos. On March of 1610, Galileo published the initial results of his telescopic observation in Starry Messenger. Galileo proved if there is no air resistance, everything falls to the ground at the same rate, regardless of its weight. Galileo stated that when gravity accelerates any object, the object accelerates at a constant rate, so that the distance fallen is proportional to the time squared. For example, a ball falling in 1 second travels 1 unit, falling for 2 seconds travels 4 units, falling for 3 seconds travels 9 units, and so on. When an object falls, it speeds up because of gravity pulling it downwards. The speed at which it accelerates is the same for all falling objects and is about 9.8 meters per second squared on Earth. Galileo, however, didn't use the word gravity at the time. He stated some force is acting on the objects falling. Gravity term was later given by Newton in 1666. It is probably a myth that he discovered this by dropping cannonballs from the Leaning Tower of Pisa. He used balls rolling down wooden ramps for most of his investigations of gravity and acceleration. While Galileo's experiments may not have been completely free from the influence of air resistance, they were successful in challenging Aristotle's ideas. He also stated the principle of inertia, where a body moving on a level surface will continue in the same direction at a constant speed unless it is disturbed. This later became Newton's first law of motion. Galileo also tried to measure the speed of light using lanterns, but he realized it was too fast for him to measure the speed of light in such small distances. It was later found by Danish astronomer Ole Romer in 1675. Galileo showed that the set of perfect squares has as many members in it as the set of whole numbers, even though at a first sight the set of whole numbers appears to contain more members. This demonstration became known as a Galileo's paradox. The basis of Galileo's proof is that there must be as many whole numbers squared as there are whole numbers, because every whole number can be squared, so every whole number can be paired up with its square. Galileo landed in great trouble because of his support to Copernican idea of heliocentrism. Ptolemy, a Greek astronomer, proposed a geocentric model of the universe in the 2nd century. According to his model, Earth was considered the stationary center of the universe, with celestial bodies including the sun, moon, planets and stars revolving around it in complex circular orbits. Ptolemy's model provided an accurate description of the motions of celestial bodies, but it had limitations and required corrections. Aristotle, a Greek philosopher, also supported the geocentric view. He argued that the earth was the center of the cosmos. Aristotle's idea held significant influence in both philosophy and natural science during his time and continued to be influential for centuries. Theories given by Ptolemy and Aristotle were also followed by the churches at the time, and that too for a very long time. People believed in Aristotle's theory for nearly 2000 years, including scientists and churches, for which Galileo faced many troubles throughout his life. Let's understand how Ptolemy and Aristotle's ideas were challenged and how we got proof of their inaccuracy. Back then, as there were no modern tools, and with the great influence of the church on the scientific aspects, it was merely impossible to imagine something like this. It was difficult for people to accept a new theory and neglecting what they believed for thousands of years. To tackle onto this, Galileo gave several observational evidence and also promoted the Copernicus model of heliocentric. He gave observation of the moons of Jupiter, how they revolved around Jupiter, and demonstrated not all celestial bodies revolved around Earth. Furthermore, Johannes Kepler, a German astronomer, gave 3 laws of planetary motion in 17th century by observations and mathematical calculation, which we will not dive into today. Galileo was a religious man. He agreed that the Bible could never be wrong. The church authorities held a literal interpretation of these passages, which they believed contradicted Galileo's heliocentric model. However, he said that the interpreters of the Bible could make mistakes, and it was a mistake to assume that the Bible had to be taken literally. This turned out to be Galileo's major mistake. At that time, only church priests were allowed to interpret the Bible. It was absolutely unthinkable for a mere member of the public to do so. These biblical passages, along with others, were used by opponents of Galileo to argue against his heliocentric views. These passages recounts the story of Joshua commanding the sun and moon to stand still, which some interpreted as implying that the sun and moon revolved around the earth. Galileo argued that this passage was not meant to be a literal description of the motion and celestial bodies, but rather a poetic or phenomenological language. This verse was often interpreted as supporting the idea that the earth is fixed and motionless. Galileo argued that this verse should be understood metaphorically rather than as a scientific statement about the earth's motion. This verse was seen by some as evidence of the sun's motion around the earth. Galileo argued that this verse was a poetic description and did not reflect the physical reality of the cosmos. The church authorities, who held a strong influence over matters of theology and interpretation of scripture, saw Galileo's ideas as contradicting the literal understanding of these passages. They feared that accepting a heliocentric model could undermine the authority of scripture and the church teachings. This was a very serious matter. Some of the churches started accusing him of heresy in this case. It means not agreeing with the Bible. Some churches went to the Inquisition. The Catholic Church court that investigated charges of heresy, and Galileo Galilei found guilty. Similar case in 1600, a man named Giordano Bruno was convicted of being a heretic for believing that the earth moved around the sun and that there were many planets throughout the universe where life, living creation of God existed. Burned to death. Galileo was ordered to appear before the Inquisition in Rome for the crime of teaching the Copernican theory after being ordered not to do so, and also banned his books. Galileo Galilei was 68 years old and sick. Threatened with torture, he was made to publicly confess that he had been wrong to have said that the earth moves around the sun. Just after his confession, Galileo quietly whispered, "And yet it moves." Galileo was confined to his house in the city of Florence for 8 years, during which time he was allowed to receive visitors. In 1638, he published his masterpiece, Discourses and Mathematical Demonstration concerning the two new sciences. The book is considered to be the most important work of Galileo. It was published in Holland after it was smuggled out of Italy. It contained much of what Galileo had discovered and learned during his many years of experiments and theories. Galileo was allowed to live under house arrest in his house outside of Florence and near one of his daughters. Until his death in 1642, he continued to investigate other areas of science. Amazingly, he even published a book on force and motion, although he had been blinded by an eye infection. The church eventually lifted the ban on Galileo's dialogue in 1822. By that time, it was a common knowledge that the earth was not the center of the universe. Still later, there were statements by the Vatican Council in the early 1960s and in 1979 that implied that Galileo was pardoned and that he suffered at the hands of the church. In 1989, Galileo Galilei's namesake, Galileo spacecraft was launched from Kennedy Space Center on its way to Jupiter and made many crucial discoveries. 3 years later, in 1992, the Vatican publicly cleared Galileo of any wrongdoing. This was today's episode. Thank you so much for watching. Don't forget to like, share and subscribe to make it reach to more people. Comment for any correction and suggestion.